All right, ladies and gentlemen, we are to the first part of our trig unit. Time for the test, so let's get down to business here. So, one-day test. So prepare appropriately. All right, find the missing side of each special right triangle. And as we are doing this, leave answers as simplified radicals. All right, first things first. When you're dealing with 30, 60, 90 triangles, reminder, hopefully we're at a point at this point. This isn't going to be. Now, Hardy, what you're not putting the x's in and stuff this time. Sometimes when x and y are the sides, that gets confusing. So I'm going to leave that part alone. I'm looking at this and I'm going, well, the 36 is the 2 or the 2x side. So if 2x equals 36, x, which is my short side, is going to be 18. And the side opposite that is going to be multiplied by the square root of 3. And we're off and running. Okay? This does not have to be rough and tough difficult for this to go well. Let's put one more over here. Hardy, are you giving us these in the test? Stop yourselves. Stop yourselves. You got to know this, or maybe write it on your test when you get it, maybe. See? Okay, so what do I have and what do I need to know? Well, I need this. If I know my short side is 9, I know this side, my long leg, is this times the square root of 3. And if this is 9 times the square root of 3, and it's a leg here, to get here we're multiplying that by 2, so this is 9 times the square root of 3 times the square root of 2, which is 9 times the square root of 6. If you're more comfortable putting x's in with these, like we have before, that's fine. I, again, just didn't want to get into confusion with that part. Okay, write in a trig equation and solve for x. Round your answers to the nearest tenth. All right. So what do we got here? So I got opposite, I got adjacent, I got hypotenuse. So for x, we're looking for opposite over adjacent, which would be tangent. Opposite over adjacent. And again, with opposite over adjacent, when we do that, we're dividing, if x is in the bottom, we're dividing by our trig function. So x looks to be 10.1. And then y is opposite over hypotenuse, which would be the sine of 56. It's opposite over hypotenuse. Same situation. Since we're dividing by the variable, we're going to be dividing by the trig function. And y ends up being 18.1. Again, if you want to multiply both sides by x and then divide by the tangent because you see it better that way, that's fine. Not a problem. Just not the way I chose to go about it. Okay, last of this one, we got an angle. I got hypotenuse, and I have adjacent, which is cosine, but remember, adjacent over hypotenuse. When it's an angle, you need to take the inverse. So second cosine. Get my value. If you practice, you're going to be able to flow like this. You seriously are. Now, first time that we may have to go to this during our time here. Again, I've got my help sheet. So if I need a little help here with the area, do a little adjusting here. Okay, that's not a problem. What you do want to take note of, though, is that you're using the two sides that create the angle. That's the angle you need to use. That is the one place we're not flexible. So 1/2 the product of the two given sides times the sine of the angle they create. If I keep that straight, we should be good. Again, if you're going to punch this in, let's just do this to make sure we don't have any confusion. It's 47.9. Do I have a measurement? Ooh, I do. Meters. square meters, because we are talking area here. Little details again, people, trying to save you from losing points on the test. All right, find the indicated measure or possible measures to the nearest 10. Find the measures of angle A. Wife's doing that. Here's my corresponding side and angle. It's B this time. If your corresponding side is less than the other side, 13 is less than 15, there could be two triangles. So I'm going to roll through the first one like we would normally do this. So I've got a corresponding side and angle. So we'll do that first. All I got otherwise is side A, so I got to look for the angle. So let's see here. 15 sine of 34. There's my diagonal without A. Divide by the diagonal with A. And take its inverse. So A number 1 would be 40.2 degrees. But let's see, is there a second? So how do I check that second again, Hardy? Oh my gosh, it's been a while. It's not in my help sheet. What do I do? Okay. When I'm trying to see if there's a second, remember, you're going to be trying to figure out, is B greater than A sine of B? We've normally done this is A and this is B, but it all comes back to the angle measure that you're working with. So what's A sine of B equal? 15 sine of 34. So 8.38. B is greater than that. So if that's the case, since B is greater than the sine of A, you're going to have two triangles. If it would have been less, B would have been less than that, I'd have had none. So just something to keep in mind. So let's find the second one. All I got to do, because I'm just looking for A, I'm not looking for the whole triangle, is to do 180 minus the measure of the angle that I already have. And just to make sure that works, as long as the two angles that you had, this new A and the B, is less than 180, yeah, that works. I am going to have a second angle. If I'd have added those two together and I didn't get something below 180, if it was more, then that's not possible. So we've got to be prepared just in case, or maybe at the minimum be prepared to know if there's 0, 1, or 2 triangles. You may have to go back and peek at some of that. Okay, let's find C. Wait, we don't have anything that matches. That's not a problem. To find B, we already know what two of the other ones are. So 180 minus 126 is 54. That's B. But that's not the answer. We want to find C. Well, now I have a corresponding side and angle. And if I want to know what C is, I'm just going to use the sine of that particular angle. Diagonal without C, divided by diagonal with C. And the rounding just takes us back down to 27. And we're rolling right along. All right, let's see what else we got here. I don't know yet if I'm doing this in one or two pieces, so we'll kind of make that judgment as we go. All right, find angle B. All I have are sides. We know what this means. We're going law cosines, people. So find B. So if I'm going to be looking for angle B, here's what we do with angles, but again, make the adjustment. The only place you're going to see side B is here at the end in the minus. So the squares of the other two minus the square of the corresponding side in parentheses. And down here, same thing. We're not using b except for there. That's how we know what numbers are going in. Again, that doesn't make sense as an answer anyway. So I work this out. B is 120 degrees on the head, and off we go. Okay, let's see what else we got. B, C, A. Nope, nothing matching up. Find the side length of A. Okay, hang on a minute here. Let's pull this back up. Don't put it away yet. Find side A. A squared equals B squared plus C squared minus 2 times B times C times the cosine of the angle. The biggest thing with these is going to be that you're taking enough time as you go through to make sure your numbers are going in right, that if you're subtracting or adding something to get there, that you're getting the right value. And square, whoops. Oh, crap. Okay, there we go. Make sure to get my square root. And it makes sense that since A is the biggest angle, it's going to be the biggest side. There's all these little things that can help you if you've been practicing. All right. Maggie's making a mosaic using triangular tiles of different shapes, so that's kind of cool. Determine the number of triangles that Maggie can form using the measurements. Okay. So you're like, wait, so what am I supposed to do? Well, let's see here. Angle A, side A, uh-oh. A is less than B. Oh, not the triangle thing again, Hardy. Yep. So, there's a couple of ways that you can take this on. Can you go back and do your B sine of A thing? Yes, and we're going to look at that in a minute. Other thing you can do is this. If you just want to go traditional, okay? If you want to use the law of sines to try and figure this out, you can. So check this out. One way you can roll, if you just want to use the calculator, and this is why sometimes I'll hold out on things for a little while, because I want you to learn the one way before we get going in all these other directions. You're like, okay, well, there's one. That's fine. How's this showing me if there's two or none or whatever? Okay, here's the deal. So now, 180 minus 50.6, we'll call this like B. It's not B squared, but I just want to make it a different show there. Here's all you have to test out to see if this worked or not, to see if there's a second triangle. We talked about this before. If you do 180 and you subtract 129.4 plus 30, and you still end up with an okay number, and you will, it means you can get a third angle. So you can get 2. Could I just have looked and tested to see the relationship between A and B sine of A? I could. If I'd have gone that route, so this just proved that these two angles can coexist in a triangle, that it doesn't equal more than 180. Mathematically, that proves it. If I do it this way, 17 times the sine of 30 degrees is 8.5. In this case, A is greater than B sine of A, because 11 is bigger than 8.5, which also tells you there are two triangles. So either of those perfectly acceptable to show me how that works. Solve the triangle by finding the missing sides and missing angles round the nearest 10th. All right, what do I got? I got me 3 sides. We've been here for this before. And we've chatted before about there's not necessarily a correct order to go with. So, if I decide to follow the rules, when we're dealing with law of cosines, we normally start with the biggest side. So, we go this route. Oh, wait, Hardy, what are you doing? You're not looking for side C? You're looking for angle C. Okay, let's try this again. Only place C is showing up is right there. Biggest ends up at the end. And again, down here in the denominator, that 30 best not show up. Don't do it. So I get to here. And I'm like, okay. Inverse of cosine is going to round to 118. So C is 118 degrees. But that's just the start of the adventure because we still need to find 2 more angles. But now I have a corresponding side and angle. And I'm back to the law of sines. Normally we use the shortest. Again, is it gonna destroy you if you went another way? Probably not. All right, let's see. 17 sine of 118 divided by the one that is going with our A. Inverse of sine, 30 degrees it is. And to finish, B is just going to be 180 minus the sum of the other 2. 180 minus 148 is 32. And we're still going. All right. Application time. Camper. Makes a makeshift tent leaning a branch against a tree and draping a tarp over it. The roof is constructed from a 15-foot branch that has a 15 angle with the ground. Approximately how tall is the tent? Make a sketch. Okay. So 15-foot branch for the roof of my tent, 15-degree angle. How tall is the tent? Seems reasonable. Okay. Opposite over hypotenuse. 15 is opposite over hypotenuse. We're just going to multiply those together because we are looking for, so about 3.9 feet. Done as done can be. The surveyor, oh, here comes the eye level question. Eye level is 6 feet above the ground. Measures the angle of elevation of the top of the highest hill in a roller coaster to be 60.7 degrees. 60.7 degrees. The surveyor is standing 120 feet from the hill's base. What is the height of the hill? Remember, at the end, we need to plus 6. So opposite over adjacent is tangent. We're going into multiply mode here. So 120 times the tangent of 60.7 is 213.8. Don't forget to add your 6. Don't add it to the decimal part. That would be silly. Get yourself set up there. I think I'm going to do this in 2 pieces. So I'm going to cut this first part of the video here, and then the last 2 pages, 14 to the end, I will be coming with again here shortly. We'll see you then.